Hello student, welcome to Study Doubt. This question is from Physics chapter Magnetism. In the question it is given that a proton, deuteron and the alpha particles are accelerated through the same potential difference and then subjected to a uniform magnetic field perpendicular to the direction of their motion. We have to find the kinetic energy relation, and if the radius of the circular path described by the proton is 5 cm, determine the radius of the path described by the deuteron and the alpha particle. So first we will understand what is proton, deuteron and the alpha particle. Protons are formed when we have hydrogen atom and we remove one of the electron from the hydrogen, so it becomes a positively charged ion. So this positively charged ion is called as proton. We can consider the mass of the proton as mp and the charge of the proton is plus E. Similarly, for the deuteron, if we have the deuterium, deuterium is the isotope of hydrogen, and we remove one of the electron, so it forms plus ion. This ion is called as deuteron. And the mass of this deuteron is 2 times the mass of proton. And its charge is same as the charge of the proton. Why? Because both has positive charge, so the charge remains the same. Alpha particle is formed when we have the helium atom and we remove 2 electrons from it, so it forms helium plus 2 ion and removal of 2 electrons. So this is the alpha particle, and the mass of the alpha particle is 4 times the mass of proton and its charge is plus 2e. Now let's understand the question. In the question, it is given that we have proton, deuteron and the alpha particle. It has to be accelerated with certain velocity, and because of this acceleration, they will reach into the magnetic field. And because it reaching into the magnetic field, there is a force developed on these protons, deuterons and the alpha particle. Because of that, it will form a circular path. And this circular path has certain radius. So now in the question, in the first part, it is given that proton, deuteron and alpha particle has same potential difference. So we know that work is equal to charge into potential. So this work is converted into the kinetic energy. So we can say that kinetic energy is equal to charge into potential. So if we consider the kinetic energy of a proton is equal to the charge of proton into the potential. Similarly, kinetic energy of the deuteron is equal to the charge of deuteron into the potential. Potential is same, so it's no change in the potential. And kinetic energy for the alpha particle is equal to 2 times of the charge of the proton into V. So from here we can relate that kinetic energy of proton is equal to the kinetic energy of deuteron. Kinetic energy of the alpha particle is 2 times of kinetic energy of proton, and it is equal to 2 times of kinetic energy of the deuteron. So this is the answer for the first part of the question. In the second part of the question, we have to find the radius of deuteron and the alpha particle. In the question, it is already given that the radius of the proton is 5 centimeter. So based on this information, we have to find the radius of deuteron and the alpha particle. So here, if we consider this is our alpha particle, when it goes into the magnetic field, it forms a radius, and this radius value is 5 centimeter. Based on this relation, we have to find the deuteron and the alpha particle radius. So let's solve it. We know that radius is equal to mass into velocity divided by q into b. This is the radius formula of a circular path. So in the question, velocity is not given. So we try to make another relation of the velocity with the electric potential. We already studied that kinetic energy is equal to Q into potential, and kinetic energy is equal to half into m into v square. So from here we can say that velocity square is 2 into q into v by m. So velocity is equal to root 2q v by m. So this relation, if we consider as relation 1, this is relation 2. So we substitute this relation. So we say that r is equal to m into root of 2qv by m into 1 by qb. So from there r is equal to root 2 mv by q into 1 by b. This relation we got. Now if we have to relate the radius for the proton, so rp is equal to 1 by b root of 2 into mp into v by e. So here rp, radius of the proton, is given 5 cm. So 5 cm is equal to 1 by b root of 2 mp into v by e. So we are going to use this relation for the further steps. Now if we have to find the radius for the deuteron, so rd is equal to 1 by b root of 2 into mass of deuteron is 2 times of mass of proton into v by plus e. This can be also written as root 2 into 1 by b into root of 2 mp into v by e. So if we use this relation here in this part, it's equal to 5 centimeter. So rd is equal to root 2 into 5 centimeter. So it's equal to 7.07 centimeter. Similarly, we have to find for alpha particle. So r alpha is equal to 1 by b root 2 into mass is 4 times of the mass of proton into v divided by charge is 2 times of the charge of proton. So this 2 and 4 gets cancelled. R alpha is equal to 1 by b into 2 into mp into v by e. Further, R alpha is equal to root 2 into 1 by b root 2 mp into v by e. So this can be written as R alpha is equal to root 2 into 5 and same as 7.07 centimeter. So from here we can say that the radius for the deuteron is 7.07 centimeter and the radius of the alpha particle is also 7.07 centimeter. So this is the answer of the second part of the question.